Imagine a single facility producing over 10 billion protein-rich insects annually, generating more edible protein per square foot than any traditional livestock operation on Earth. Right now, across specialized farms from Texas to California, millions of locusts are being cultivated in climate-controlled environments that rival the sophistication of any modern agricultural operation. These facilities can produce 20,000 pounds of high-quality protein per day using a fraction of the water, land, and feed required for conventional meat production. But how do you manage billions of jumping, flying insects in controlled environments? What cutting-edge technology transforms these ancient agricultural pests into premium protein sources for both human consumption and animal feed? How has an industry that barely existed a decade ago become one of the fastest-growing sectors in American agriculture? Welcome to AgriCraft, where we explore the incredible innovations shaping modern farming and food processing technology. Today, we're diving deep into the remarkable world of industrial locust farming. From breeding colonies to finished protein products, all will be revealed in this video. The transformation of locusts from devastating agricultural pests to valuable protein sources represents one of the most dramatic shifts in modern farming history. For thousands of years, locust swarms terrorized farmers across every continent, destroying crops and causing famines that shaped human civilization. Ancient texts from Egypt, China, and the Americas describe locust plagues as divine punishment, with single swarms containing billions of insects capable of consuming entire harvests in hours. The modern locust farming industry emerged from this historical antagonism through the work of entomologists and agricultural researchers who recognized the incredible efficiency of insect protein production. In the 1970s, scientists began studying how traditional cultures in Africa, Asia, and Latin America had long harvested wild locusts as nutritious food sources during swarming events. These communities understood what modern nutrition science would later confirm. Locusts contain more protein per pound than beef, chicken, or fish, while requiring dramatically fewer resources to produce. Commercial locust farming began in earnest during the early 2000s as entrepreneurs and agricultural innovators recognized the enormous potential of controlled insect cultivation. The first commercial facilities were small-scale operations focused primarily on pet food and exotic animal feed markets. However, as concerns about food security, environmental sustainability, and protein demand grew, investors and agricultural companies began developing industrial-scale locust farming operations. Today, the global edible insect market generates over $4 billion annually, with locust farming representing the fastest-growing segment. The Netherlands leads European production with over 50 commercial facilities processing millions of locusts weekly, while Thailand and Vietnam dominate Asian markets with integrated farming operations that supply both domestic and export markets. The United States entered the industry more recently but has quickly become a major player, with facilities in agricultural states like Iowa, Nebraska, and California producing insects for both food and feed applications. What makes locust farming so compelling to modern agribusiness professionals is the remarkable resource efficiency these insects demonstrate. Locusts convert feed to protein at rates that surpass any conventional livestock, requiring only 2 pounds of feed to produce 1 pound of protein compared to 8 pounds of feed needed for beef production. They reach harvest maturity in just 6 to 8 weeks, compared to months or years for traditional livestock, enabling multiple production cycles annually that maximize facility, utilization, and profitability. The foundation of industrial locust cultivation begins with carefully managed breeding colonies, housed in specialized facilities designed to optimize reproduction and population growth. Unlike traditional livestock breeding, locust farming requires precise environmental control systems that maintain temperature, humidity, and lighting conditions within narrow parameters that trigger natural breeding behaviors. These breeding facilities feature climate-controlled chambers with computerized monitoring systems that track environmental conditions 24 hours daily. Professional locust breeders maintain genetic diversity through careful colony management that prevents inbreeding, while selecting for traits like rapid growth, high feed conversion, efficiency, and disease resistance. Breeding females can lay up to 100 eggs in specialized substrate materials that provide optimal conditions for egg development and hatching. The incubation process requires precisely controlled soil, moisture, and temperature that varies by locust species and desired production outcomes. Modern breeding facilities house thousands of breeding adults in mesh enclosures that allow natural movement and feeding behaviors while preventing escapes that could create environmental concerns. These enclosures feature automated feeding systems that distribute fresh vegetation and specialized insect feeds throughout the day, ensuring consistent nutrition that supports high reproduction rates and healthy offspring development. The egg-laying substrate consists of specially prepared mixtures of sand, soil, and organic matter that mimics natural conditions while providing optimal moisture retention and aeration for developing eggs. This substrate undergoes regular testing and replacement to maintain the precise conditions required for maximum hatch rates and healthy nymph development. The substrate preparation represents a critical component of successful locust farming that requires both scientific knowledge and practical farming experience. Temperature management throughout the breeding cycle utilizes sophisticated heating and cooling systems that maintain optimal conditions for each development stage. Young nymphs require slightly higher temperatures than adults, necessitating separate climate zones within breeding facilities that can be independently controlled and monitored. These environmental control systems represent significant investments but are essential for achieving the consistent production volumes that commercial operations require. As locust nymphs emerge from their eggs, they enter a carefully managed growth phase that transforms them from tiny insects into harvest-ready adults in just weeks. This rapid development cycle requires intensive management of feeding, environmental conditions, and population density to ensure optimal growth rates while preventing overcrowding that can trigger stress responses and reduce survival rates. The feeding regimen for growing locusts combines fresh vegetation with specialized insect feeds formulated to provide optimal nutrition for rapid growth and high protein content. Modern locust farms utilize hydroponic systems to produce fresh grasses and leafy vegetables year-round, ensuring consistent feed quality regardless of seasonal variations or weather conditions. These hydroponic facilities operate alongside insect production areas, creating integrated farming systems that maximize resource efficiency. Automated feeding systems distribute measured portions of feed throughout locust enclosures multiple times daily, ensuring that all insects have access to adequate nutrition during their rapid growth phases. These feeding systems incorporate sensors that monitor feed consumption patterns and adjust distribution schedules based on population size and growth stage requirements. The precision feeding approach minimizes waste while maximizing growth rates and protein content. Population management becomes critical as locusts mature, as overcrowding can trigger swarming behaviors that reduce individual insect quality while creating management challenges. Professional locust farmers maintain optimal densities through careful monitoring and periodic redistribution of insects among growing enclosures. This population management requires extensive experience and understanding of locust behavior patterns that vary by species and environmental conditions. Environmental enrichment within growing facilities includes vegetation structures and substrate materials that allow natural behaviors while maintaining the controlled conditions necessary for commercial production. These enrichment features reduce stress and promote healthy development while facilitating easier management and harvesting operations. The design of growing environments represents a balance between natural insect behaviors and commercial production requirements. When locusts reach optimal size and protein content after 6 to 8 weeks of intensive cultivation, they enter the harvest phase of commercial production. This timing represents the peak protein content before insects begin reproductive activities that can reduce meat quality and nutritional value. The harvest process requires specialized techniques and equipment designed specifically for efficient insect collection and handling. Professional locust harvesting begins with environmental manipulation that temporarily reduces insect activity and makes collection safer and more efficient. This typically involves lowering temperatures in growing enclosures to slow insect movement while maintaining conditions that preserve quality and minimize stress. The temperature reduction creates a window of opportunity for mechanical collection without requiring chemical interventions that could affect product quality. Mechanical harvesting systems utilize specialized vacuum collection equipment designed to gather large volumes of insects quickly while minimizing damage that could affect processing outcomes. These collection systems incorporate filters and sorting mechanisms that separate insects by size and remove debris or damaged specimens that could compromise final product quality. The harvesting equipment represents custom-engineered solutions developed specifically for commercial insect farming applications. Transportation from growing facilities to processing plants requires specialized containers and handling procedures that maintain insect quality. while preventing escapes during transit. Refrigerated transport vehicles maintain optimal temperatures that preserve freshness while reducing insect activity during movement. The transportation logistics resemble those used for other perishable agricultural products, but require specialized equipment and procedures adapted for insect handling. Processing facilities for locusts incorporate food safety standards and industrial machinery, adapted specifically for insect processing requirements. These facilities feature automated systems that handle the massive volumes of insects produced by commercial farming operations, while maintaining the hygiene standards and quality control procedures required for food and feed. Applications. The processing plants combine traditional food processing technology with innovations developed specifically for insect agriculture. The initial processing steps involve comprehensive cleaning procedures that remove any debris or foreign materials, while preparing insects for further processing. Industrial washing systems utilize clean water and food-grade sanitizing solutions to ensure product cleanliness and safety. These washing systems process thousands of pounds of insects hourly, while maintaining the gentle handling required to preserve product integrity and nutritional value. Sorting and grading operations separate insects by size, quality, and intended use through automated systems that utilize optical scanning and mechanical separation techniques. Premium-grade insects destined for human food applications undergo more rigorous sorting than those intended for animal feed production. This sorting process ensures that final products meet the specific quality standards required for different market segments and applications. Temperature control throughout processing maintains optimal conditions that preserve nutritional content while ensuring food safety compliance. Processing facilities utilize both refrigeration and controlled atmosphere systems that maintain product quality during the various processing stages. These environmental controls represent critical investments that enable consistent product quality regardless of external weather conditions or seasonal variations. Sterilization procedures eliminate potential pathogens while preserving nutritional value through carefully controlled heat treatment processes. These sterilization systems utilize precise temperature and timing controls that ensure safety while maintaining the protein quality and digestibility that make Locust products so valuable. The sterilization process follows established food safety protocols adapted specifically for insect products. Quality inspection procedures at multiple processing stages ensure that only premium products reach consumer and commercial markets. Trained inspectors examine product samples for visual quality, contamination, and adherence to established standards that govern both food and feed applications. These quality control measures include laboratory testing that verifies nutritional content and safety parameters throughout the production process. Processing continues with specialized equipment that transforms whole insects into various products ranging from whole roasted locusts for human consumption to protein powders for animal feed applications. Grinding and milling operations utilize industrial equipment adapted for insect processing, creating consistent particle sizes and textures that meet specific customer requirements. These processing capabilities enable producers to serve diverse markets with customized products. Automated packaging systems handle the enormous volumes of processed insect products while maintaining the cleanliness and precision required for food applications. These packaging lines incorporate weighing systems, sealing equipment, and labeling machinery that creates finished products ready for distribution. The packaging equipment represents sophisticated automation technology, adapted specifically for insect product handling requirements. Vacuum packaging systems extend shelf life while preserving nutritional quality through controlled atmosphere packaging that prevents oxidation and spoilage. These packaging systems utilize barrier materials specifically selected for insect products, ensuring extended storage life while maintaining product quality during distribution and storage. The packaging technology enables long-distance shipping and extended retail display periods that expand market opportunities. Product labeling includes detailed nutritional information, preparation instructions, and traceability data that meets regulatory requirements while providing consumers with comprehensive product information. Automated labeling systems apply this information consistently across high-volume production runs, while maintaining accuracy and compliance with food labeling regulations. The labeling process incorporates tracking systems that enable complete product traceability from farm to consumer. Distribution networks for Locust products serve both domestic and international markets through specialized supply chains adapted for insect product handling and storage. These distribution systems include temperature-controlled warehousing, specialized transportation equipment, and inventory management systems that ensure product quality throughout the supply chain. The logistics networks resemble those used for other protein products, but incorporate unique requirements for insect products. Cold storage facilities maintain optimal temperatures for different product types while providing the capacity needed for high-volume commercial operations. Frozen insect products require continuous temperature control that preserves nutritional value and extends shelf life for global distribution. These storage systems incorporate monitoring technology that tracks temperature conditions and alerts operators to any deviations that could affect product quality. International shipping capabilities enable American locust producers to serve growing global markets for insect protein products. Export operations require specialized documentation and compliance with international food safety standards that vary by destination country. The export logistics incorporate the same quality controls and temperature management used for domestic distribution while meeting additional requirements for international trade. The comprehensive utilization of locust biomass extends beyond primary protein products to include valuable byproducts that maximize economic returns from each insect processed. Locust oil extracted during processing contains beneficial fatty acids that command premium prices in nutritional supplement and cosmetic applications. This oil processing requires specialized extraction equipment that separates and purifies lipid components into pharmaceutical-grade products. Chitin extraction from locust exoskeletons produces valuable biomaterials used in biodegradable packaging, medical applications, and agricultural products like natural fertilizers and soil amendments. This chitin processing utilizes chemical and mechanical separation techniques that recover valuable materials while minimizing waste production. The chitin extraction represents an additional revenue stream that improves overall production economics. Frass, the waste material produced during locust cultivation, serves as an excellent organic fertilizer that provides both nutrients and beneficial microorganisms for crop production. This frass processing creates valuable agricultural products while managing waste streams from insect farming operations. The fertilizer production demonstrates how integrated agricultural systems can minimize waste while creating additional value streams. The culinary applications for locust products continue expanding as consumer awareness grows about the nutritional benefits and environmental advantages of insect protein. Premium restaurants increasingly feature locust-based dishes that showcase the nutty, savory flavors that make these insects appealing to adventurous diners. Professional chefs develop preparation techniques that highlight locust protein while addressing texture and presentation concerns that influence consumer acceptance. Whole roasted locusts serve as protein-rich snacks that provide portable nutrition for outdoor enthusiasts, health-conscious consumers, and international markets where insect consumption represents traditional dietary practices. The roasting process enhances flavor while creating shelf-stable products that require no refrigeration during storage and transport. These whole insect products represent premium market segments that command higher prices than processed protein powders. Ground locust protein powders provide versatile ingredients for food manufacturers developing protein-enriched products ranging from energy bars and beverages to baked goods and meat alternatives. These protein powders offer neutral flavors that blend easily with other ingredients while providing complete amino acid profiles that rival traditional protein sources. The powder processing enables incorporation into existing food manufacturing systems without requiring specialized equipment. Nutritional analysis reveals that locust protein contains all essential amino acids required for human nutrition, while providing significant amounts of vitamins and minerals, including B vitamins, iron, zinc, and magnesium. The protein content ranges from 60 to 70% by dry weight, substantially higher than most conventional protein sources. This exceptional nutritional density makes locust products particularly valuable for addressing malnutrition and protein deficiency in developing regions. The digestibility of locust protein exceeds that of many plant-based proteins, while remaining more environmentally sustainable than animal proteins from conventional livestock. Research indicates that locust protein digestibility rates approach 90%, ensuring that the high protein content translates into bioavailable nutrition for consumers. This digestibility advantage positions insect proteins as superior alternatives to traditional protein sources for both human and animal nutrition. Micronutrient content in locusts includes significant levels of iron in highly bioavailable forms that address iron deficiency concerns affecting billions of people worldwide. The iron content in locusts exceeds that found in beef, while providing additional micronutrients that support immune function and overall health. These nutritional advantages support growing interest in insect proteins as solutions for global nutrition challenges. Environmental considerations surrounding locust farming reveal dramatic advantages over conventional livestock production in terms of resource efficiency and ecological impact. Locust farming requires over 90% less water than beef production while generating virtually no greenhouse gas emissions. The land use efficiency enables protein production in urban environments and areas unsuitable for traditional agriculture, potentially revolutionizing food production systems. The carbon footprint of locust farming approaches carbon neutrality due to the minimal energy requirements for production and the absence of methane emissions associated with ruminant livestock. Life cycle analyses indicate that locust protein generates less than 1% of the greenhouse gas emissions produced by equivalent amounts of beef protein. These environmental advantages position insect farming as essential technology for sustainable food production. Waste reduction through comprehensive biomass utilization ensures that locust farming generates minimal environmental impact while maximizing resource efficiency. The closed-loop production systems recycle organic waste into feed materials while producing valuable byproducts that serve agricultural and industrial applications. This circular economy approach demonstrates how modern agriculture can minimize environmental impact while maximizing productivity. Feed conversion efficiency in locust farming surpasses all conventional livestock, while utilizing feed materials that include agricultural waste products and specially cultivated crops requiring minimal resources. The ability to convert low-value organic materials into high-quality protein represents a fundamental advantage of insect agriculture over traditional livestock production. This efficiency enables protein production in resource-constrained environments where conventional agriculture is impractical. The remarkable journey from locust egg to finished protein products demonstrates how agricultural innovation can transform traditional pest species into valuable food resources through sophisticated farming and processing systems. Modern locust farming combines biological understanding with industrial technology to create production systems that address growing global demand for sustainable protein while minimizing environmental impact. The scalability of locust farming operations enables rapid expansion to meet increasing market demand without requiring the massive land and resource investments associated with conventional livestock agriculture. Individual facilities can produce millions of pounds of protein annually while occupying relatively small areas and utilizing minimal water and energy resources. This scalability positions insect farming as a viable solution for feeding growing global populations. Technological advancement in locust farming continues driving improvements in production efficiency, product quality, and cost-effectiveness that enhance competitiveness with traditional protein sources. Automation systems, environmental controls, and processing equipment specifically designed for insect agriculture enable increasingly sophisticated operations that achieve economies of scale previously thought impossible for alternative protein production. The integration of locust farming with existing agricultural systems creates opportunities for diversification and risk management that benefit rural communities and agricultural economies. Farmers can incorporate insect production into existing operations while utilizing agricultural waste products and creating additional revenue streams that improve economic resilience. This integration demonstrates how innovative agriculture can strengthen rather than replace traditional farming systems. Economic impact studies indicate that commercial locust farming creates employment opportunities in rural areas, while generating export revenues that contribute to agricultural trade balances. The high-value nature of processed insect products enables profitable operations even at relatively small scales, making locust farming accessible to entrepreneurial farmers and agricultural innovators seeking new opportunities in sustainable food production. As global awareness of environmental sustainability and food security challenges continues growing, locust farming represents a proven solution that addresses multiple concerns through innovative agricultural practices. The combination of exceptional nutritional value, minimal environmental impact, and efficient resource utilization creates compelling value propositions for consumers, investors, and policymakers seeking sustainable food production alternatives. Thank you for joining us on this fascinating exploration of industrial locust farming, where cutting-edge agriculture technology transforms ancient agricultural pests into tomorrow's protein solutions. The sophistication and potential of this industry demonstrate the incredible innovation happening in American agriculture, creating new opportunities for farmers, while addressing global challenges in food security and environmental sustainability. If you found this behind-the-scenes look at locust farming as captivating as we did, please give this video a like and subscribe to AgriCraft for more amazing stories from the world of modern farming and food processing technology. What other innovative agricultural practices would you like us to investigate? Share your thoughts in the comments below, and we'll continue bringing you the remarkable stories of how agricultural innovation is transforming food production and creating opportunities for the next generation of American farmers and agribusiness professionals.